So in 5.1 and 5.2, we looked at exponents, and one of the questions that I got sent was this one. And on your particular MyLabs Plus homework, your problem might be different, but it should have the same basic structure. And I thought we would talk about it and look at some of the pieces and just to kind of get a nice review of some of these exponential tools. That is a 5 there. So to remind you really briefly of our exponential tools from the section, we did learn that if we are multiplying two things together that are exponentials with the same base, we add them. And the reason we add them is the exponents tell us about multiplication anyway. So this is already saying x times x. This one is saying x times x times x because there's 3 of them. So here we're multiplying 2 x's together, there we're multiplying 3 x's together, so all told we're multiplying 2 plus 3, or 5 x's together. So when we're multiplying, we just add the powers together if the bases match. Similarly, if we're dividing, this is 3x's over 2x's, and they would cancel. X times x times x over x times x. Every pair of x's would divide out into a 1. So both of these are going to subtract from the 3 on top. And we get a nice rule. Dividing two things with the same base, we subtract their exponents. Our last big rule from beginning exponents is what happens when you raise something to a power. Well, if this is supposed to be 3 of those, this power of 3, exponent of 3 out here says you've got this multiplied by itself 3 times. If we write that out, that's going to be x squared times x squared times x squared, which is 2 x's multiplied by 2 x's multiplied by 2 more x's. We have a total of 2 times 3, or 6 x's. So when we're multiplying exponents with the same base, we add. When we're dividing exponents with the same base, we subtract. When we're raising something with an exponent to another exponent, we multiply. Now, some of the consequences of these tools tell us something about negative exponents. This ended up being a positive 1 because this 3 was larger than that 2. But if it was the other way around, we would have gotten a negative. And it's nice to look at what that means. Well, to just remind you what exponents mean in general, if we talk about 2 to the third, that means, by definition, 2 times 2 times 2. This says we're multiplying by 2 3 times. 2 squared says multiply by 2 twice. 2 to the first says multiply by 2 once. 2 to the 0 says don't multiply by 2. You're multiplying by 2 0 times. Well, not multiplying by 2 shouldn't do anything. What's the only thing you can multiply by that doesn't do anything? Is a 1. That sometimes throws people off. They want this to be a 0. But in multiplication, 0 does a lot. It destroys things. It's the great destroyer when you multiply by it. This says, if I have a 5, don't multiply it by 2. Well, it's the same thing as multiplying by 1. Also, if you look at this pattern, 2 to the third is 8. 2 squared is 4. 2 to the first is, well, just 2. But half of 8 is 4. Half of 4 is 2. Half of that 2 gets us down to a 1. So if we follow the pattern, this should really be a 1. There are other reasons. Your book talks about some of them, but always keep in mind that 2 to the 0. Sorry for the shaking there. But if we follow this pattern and look at negative exponents, these exponents are telling us how often we multiply. Well, negative says opposite. So this is saying do the opposite of multiplying by 2 once. Well, what's the opposite of multiplying? Well, dividing. So we divide by 2 instead. 2 to the negative 2. Well, again, do the opposite of multiplying by 2 twice. Okay, I'm going to divide by 2 twice. 2 to the negative 3. Same thing. That negative says do the opposite of multiplication, which means dividing. Oops, sorry. Sometimes we have to separate the idea of negatives as in what we normally think of with negative numbers and negatives in this opposite language. The negative, that little dash, tells us the opposite. Yes, the additive opposite is a negative number, but this isn't saying a negative in quite the same way as we normally think of a negative. So that's just something to make sure that we're careful of. So if we have something like x to the negative 5, well, this, instead of saying multiply by x the opposite of 5 times, we're dividing by that x 5 times. So it just moves it from the top down to the bottom. Oops, sorry. So that x to the negative 5 would become 1 over x to the 5th. Similarly, if we are in a denominator already and negative, if we said, let's say, x to the negative 3, we could express that as 1 over x to the negative 3 is 1 over x to the 3rd. But then we have this complex fraction, this fraction inside our fraction, and nobody likes that. But we know how to divide by fractions. We multiply by the reciprocal. So 1 times the reciprocal of this, x to the 3rd over 1, would just be x to the 3rd. So notice that this negative sign, if it's in the denominator already, it moves up to the numerator over 1. If it's in the denominator, if it's already essentially on top in a numerator, the negative makes us move down to a denominator. So if we had something like 3x to the negative 4 over y to the negative 2, this negative 4 is saying do the opposite of where it is. So instead of having it on top, we're going to put that x to the negative 4, bring it to the bottom, and it will become positive. Similarly, we could turn this y to the negative 2 into 1 over y squared like we did here, but in practice, it really is just saying, I'm in the wrong place. Move me. Instead of having this y to the negative 2 down here, we're going to move it on top, y squared. Notice this 3 doesn't have a power on it. This negative 4 is only on the x, so it didn't move when we moved the x to the 4th down. This 3 is just being multiplied by that, so that's going to stay up on top and be multiplied. If it had a negative exponent on it itself, we could move it, but be careful. This negative 4 is not on that 3, so it's not going to move. So we get used to the idea that negatives just essentially move us, negative exponents, move us from the top to the bottom. But again, you got to separate that from the idea of a negative number. If that was a negative 3, that negative 3, negative numbers don't move down. Negative exponents tell us to move down or up. So that negative 3 would just stay a negative 3. I don't want you to get it in your head that negative numbers mean we should be dividing instead. It's the exponents that communicate that to us. So if we put these rules together to try to approach a problem like this, let me add one rule here. Let me add it over here. The only one that we really haven't talked about is if you have a times b to a power. So let's say we have a times b squared. That technically means a times b. Sorry about that. Times a times b. But with multiplication, we can really multiply in any order. So this is a times b times a times b, or a squared times b squared, because it's a times a and b times b. So when we have a product already, and that product is being raised to a power, we can simply raise the different pieces to a power. So for example, if we had just 5x quantity squared, we've got 2 5s and 2 x's, so it's a nice 5 squared x squared. 5 squared we can evaluate is 25 x squared. So again, when we have a product, and it doesn't matter actually how many we have. If we have, say, 2x to the third y squared all to the, I don't know, fourth power, each part of this product, each factor in that product, is going to be raised to that general power. So 2 to the fourth, which is what, 16. X to the third to the fourth, and again, when we raise a power to a power, we multiply. So x to the third raised to the fourth is x to the 12th. Y squared to the fourth, when we raise a power to a power, we again multiply, so to the 8th. And if you wanted to write that something in between, that is 2 to the fourth, x to the third to the fourth, and y squared to the fourth. And again, powers to powers, we multiply. Do be careful. Sorry. This can be a very dangerous rule because it's often overused. If we have x plus 2 squared, we can't just do the same thing we did up here. This is a product. Exponents like to talk to products. It works because of this commutative property down here. This is not equal to x squared plus 2 squared. It doesn't work. You can't do it. This means x plus 2 times x plus 2. So we have to handle this in a different way, and we'll talk about it in the coming sections. So be very careful. This, called the distributing exponents over multiplication, only works when these are multiplied together, when this is a product, not when they're separate terms in a sum. So do be careful about that. Okay, now let's use all this to try to tackle this problem. We do want to break it essentially into sections. So this section up here, this 3x squared quantity squared, this is a product being raised to a power. So we're going to raise each of those pieces to a power. The 3 squared, and just to be real detailed here, x squared squared. And then I'm going to write the x to the 4x to the negative 2 over x to the 4th to the 5th, just so I don't lose anything. So this x squared quantity squared, when you raise a power to a power, you multiply. So that is 2 times 2. So 3 squared is 9 while I'm at it. X to the 4th times 4x to the negative 2 over, again, while I'm at it, I might as well do these, x to the 4th raised to the 5th. Power to a power, we multiply, so we get a big x to the 20th. I'm going to rearrange some terms here. You wouldn't necessarily have to write this, but just to be clear, I'm just kind of reorganizing these. Again, the commutative and associative properties of multiplication. But in practice, you can just do the 4 times 9 separately and without having to write this in between. But just to be super clear, 9 times 4 is 36. This is a product of two things with the same base. Well, when we have two things with the same base, we added the powers. Just because this is negative doesn't change that rule. So this is x to the 4 minus 2. And 4 minus 2 is 2. So it's 36x squared over x to the 20th. Now we could also have moved it down and then added it to the 20 and gotten a 22 down there, and it would have ended up being the same thing by the time we were done. But really, adding it here is probably just as easy. So this 36 is going to keep coming along. But again, here we have two things with the same base. Two things with the same base and different powers. They're being divided. I'm going to focus just on these two pieces here. And our rule for division said if we're dividing two things with the same power, we subtract them. So you've got x to the, notice the order of subtraction, top minus bottom. So our top is a 2 minus the bottom is an 18. And notice this is all essentially over 1, because this is all over 1 over 1. So we're going to end up with this 36x to the negative 16 in the numerator. But that negative 16 is kind of saying, I don't want to be in a numerator. So we get 36 over x to the 16. And that should be our final answer. So there's a lot of manipulation in here, and a lot of things you could frankly have done in different orders. You could have brought this x squared down, x squared. That would have turned it into a 22. So we would have x to the 4th over x to the 22nd. But 4 minus 22 is still the same 16. No, it's not. It was straight to 18. Oh, sorry, I did my subtraction there. That's supposed to be a 20. 2 minus 20 is negative 18. I subtracted it twice. That's why you have to practice these things. So anyway, if we brought it down, we'd have a 22, and 4 minus 22 would give us the same 18 that we got when we did this the right way. So you have a lot of options in the order in which you do these problems, but it's always based around these rules of exponents. Well, hopefully that's helpful in giving some perspective. There's a lot of information in there. And if there's anything you need, again, you want questions with problems like this, you have other questions, let me know.